Hello, this is problem set number 4, problem 2. The Otto cycle engine in a Mercedes-Benz SLK 230 has a compression ratio of 8.8. Part A, what is the ideal efficiency of the engine? And use 1.40 as a value for ratio of molar heat capacity. For part B, the engine in the Dodge Viper GT2 has a slightly higher compression ratio of 9.6. How much increase in the ideal efficiency results from this increase in the compression ratio? Okay, let's start with a problem for part A. Okay, so part A, write down our givens for the SLK 230. Its engine has a compression ratio of R equals 8.8, and we're going to use 1.4 as a value for ratio of molar heat capacity, which is symbolized by gamma. So 1.4, gamma is 1.4. Okay. And in order to solve this problem, we should know that the Otto cycle engine ideal efficiency formula, which I'll write here in the blue ink, is equal to 1 minus the compression ratio to the power of 1 minus gamma, or ratio of molar heat capacity. Okay, so this would be something, you could find this in the book, or for a test, maybe you would have this in your cheat sheet. Again, this is the Otto cycle engine ideal efficiency formula. Okay, R is the compression ratio. And gamma is a ratio of molar heat capacity. Okay, so at this point, it's going to be pretty simple. We'll find E because we are given R as 8.8 for the SLK 230, and to the power of 1 minus gamma, which is 1.40. Right? Okay, so if you plug that in the calculator, you would find that that is equal to 0.581. Okay, so E SLK 230 is that, and that is our final answer. So the ideal efficiency is the ideal efficiency of the SLK 230 engine is 58.1%. Okay, that's our answer for part A. All right, and for part B, now we will compare part A to what we will find as the ideal efficiency in the Dodge Viper GT2 with a slightly higher compression ratio of 9.6. So for the GT2, it has a compression ratio, its engine has a compression ratio of 9.6, and we'll use 1.4 for gamma as well, similar to part A. So again, I'll just use this formula for the Otto cycle engine ideal efficiency, and I would get that for the GT2, that's equal to 1 minus 9.6 to the power of 1 minus gamma, which is 1.40. All right, and if I plug that in the calculator, that would equal 0.595, That's GT2. So efficiency for the GT2 is 0.595 or 59.5%. And the problem wants us to compare how much is the increase in ideal efficiency resulting from the increase in the compression ratio, right? So we increase compression ratio from 8.8 to 9.6, and we see that we have an increase in ideal efficiency, right? So if I compare that, I would say that the increase in compression ratio yields an increase in ideal efficiency of 1.4%. Right? And that is just subtracting 59.5% by 58.1% from part A. All right, so if you notice the increase in compression ratio R from 8.8 to 9.6 and also increase the ideal efficiency of the Otto cycle engine from 58.1% to 59.5%. Okay.